Hi, my name is Jacob Morris, and this is my final presentation video on potential improvements to the Map-Elites evolutionary algorithm. Map-Elites is a relatively new evolutionary search algorithm, and unlike previous algorithms, it highlights the trade-offs of performance across various dimensions of a defined feature space. I will use the following comparison metrics to track the performance of each experimental treatment relative to the control, which is the base Map-Elites algorithm. These metrics are designed to track not only how fit of individuals a given run produces, but also how well it does at illuminating the search space. For my first problem domain, I chose to evolve what I call box bots, which are expressed through a generative encoding known as a compositional pattern producing network. The initial population is seeded with a number of individuals that then have the Map-Elites algorithm applied to them through 250 generations or 2,500 evaluations to produce a final population of elite evolved box bots. The heat map shown here shows the most fit individuals found by any run of any treatment for the boxbot problem domain, and also reveals the chosen dimensions for this problem domain, which is the box count, or just the number of boxes in a given bot. It's up to 25, and also the length of the bot, which is the greatest distance between any two boxes. My first experimental treatment reveals a theme that will be carried across most of the treatments, which is the idea of allowing more than one individual per cell of the feature space, unlike the base Map-Elites algorithm. In this case, each newly created individual is given an incubation period of 1 generation, and is not subject to deletion until that incubation period expires. The data presented here shows that there is not a significant statistical difference between the base Map-Elites algorithm and an incubation period of 1. Moving on to an incubation period of 4 generations, we actually see a decrease in performance in the measures of illumination relative to the base Map-Elites algorithm. The next treatment enforces elitism in a slightly different way than the base Map-Elites algorithm. Where the base algorithm only allows one individual per cell location, this treatment allows multiple individuals, in this case 2. Elitism is still enforced in that these are the 2 most fit individuals encountered during the run thus far, and as we can see from the data here, this actually does produce a slight boost in the overall performance, in other words, the most fit individual produced during the run, but no real change in the illumination produced by the algorithm. As can be seen here, increasing the number of individuals allowed to 10 actually decreases performance relative to the previous treatment, and produces worse results in illumination relative to the base Map-Elites algorithm. For the next treatment, rather than enforcing a maximum cell population, I enforce a maximum population on the feature space as a whole, such that the most elite individual per cell is safe, but only a certain number of individuals after that are allowed to live. In this case, 25% of the possible total max population, or 100 individuals, are allowed to live after that. And as you can see, this actually hurts performance quite a bit. For my final treatment, I tried increasing the rate of selection for producing children on each generation for individuals that are within distance 1 of an empty cell in the feature space. Basically, they get twice the rate of selection as other individuals. This produces pretty similar results to the base Map-Elites algorithm. This graph shows the median fitness over time of each of the treatments previously discussed, and it actually reveals the biggest flaw with my experiments, which is that the experiment should have been run for a longer amount of generations, but I was limited by computation power and the deadline for this video, so that will have to be done at a future date. Finally, we have the orphan rates for each of the experimental treatments, and this is the most promising result of my experiments because it shows that nearly all of the individuals that are locally elite at the end of a run have somewhere in their lineage a parent that was not locally elite. In other words, they might not exist without the modifications made for these treatments.